Yeah, then the second one is of 8 because it can't be repeated.
Right, so first of all, you're going to check how many letters do we have here, guys?
8.
6-letter word. Are there 6 letters? 1, 2, 3, 8 letters, but only 1 6, eh?
Yes.
Okay. And the letters can be repeated. Okay. So how many spaces do we have? Remember, guys, as soon as you start drawing these little lines in, like this, okay, then the number that go in there, the number of choices is not factorial. Okay. So once you start doing that, you've got 6. 1, 2, 3, 4, 5, 6 things, right? Okay. And how many choices do we have for each letter, each space? For the first one, you've got how many choices? 8. The next one? 7. The next one? 6. The next one? 5. There's no factorial in this. Okay. Because we're looking at number of choices. Think of a menu. Sorry?
Yeah.
Oh, they can be repeated. Sorry. Question 1. Okay.
You shouldn't have erased it, sir. It's still
Wasn't
right.
right. Okay, so here you've got 8 times 8 times 8 times 8 times 8. Sorry, guys. 5 times 8, right? Okay. Because the letters can be repeated. So you have 8 choices for each space. Okay, so it's going to be 8 to the power of 6, right? Which is what?
Yes, you're so right.
With 8 to the 6?
262,144.
Okay.
Yes, sir.
Alright, but the next one, the letters cannot be repeated. Okay, so it's going to be 8, 7, 6, 5, 4, 3, right? Are we happy with that idea, guys?
Yes.
What does that give you?
20,106.
Don't worry about the number. Just worry about your questions.
3, 5, 1, 7. No, I was thinking of it random. At the same time from the box.
Same time doesn't actually matter about the same time. It just means they're just taken out of the place, that's all it means. Okay, it doesn't have to say at the same time. You take out one, you take out another. Okay, you don't put one back. That's what they're saying is you don't put one back. Okay. So in your tree diagram, you've got the first globe that you pull out, and then you've got the second globe you pull out.
So 15.
Okay? And for each one you've got 3 choices.
Other take a walk.
You're right. Yeah, you're right.
So then,
Yes.
after that you can pick another.
Oh no!
You can, that is not what I do.
And then you're going to put the probabilities on each branch, guys. Okay. So how many globes do we have in total? 3, 8, you've got 15 bulbs, right?
Yes.
Of those, okay. So 3 out of every 15, okay, is going to be a 40-watt bulb, right? In other words, the probability of getting a 40-watt bulb is what? 1 out of 5. You agree? Okay.
Can you just leave it as
Okay. Are you happy with that? Or you can give it a 3 over 15.
Sir, Bastian.
Okay. The probability of getting, okay, a 60 watt How many 60 watts were there? 5 out of 15, right?
Yeah.
You can leave it as 5 over 15 or you can write it as 1 over 3. What they did in the memo. In the memo they kept it, I also prefer leaving them all over 15 so that you can see that they add up to 1. Okay, so I'm going to use, it's not wrong not to, but 40 watts I'm going to use 3 over 15, 60 watt I'm going to use 5 over 15, okay, and then 100 watts is going to be 7 over 15 because it's just a nice little check. So you're going to say 40, 3 over 15, 60 was 5 over 15. This must be, what has to happen for each sub-branch of an app? What do those probabilities always have to add up to? 1 in each sub-branch, right? Okay, so then I'm going to have 3 over 15, 5 over 15, 7 over 15, 3 over 15, same pattern, eh? Okay, 5 over 15, 7 over 15. What's wrong? Remo?
Why is it not like, I thought we go down, like the diagrams?
No, because they happen at the same time. Okay, so there is, okay, actually what they mean, okay,
Like 1 and 2.
because they came out at the same time,
Oh.
let's just double check. Oh no, I'm wrong. Okay, no, okay. Undo. Right, pause, my bad. I've lost focus. Right. Okay, I don't like the way it's phrased. Okay. So, there's no way, I don't like the way they say at the same time.
Yes.
Okay?
It should be one.
I really think what they're meaning is you take one, then you take another. And there's no replacement. That's how I would phrase the question.
Yeah.
Okay. Does that make sense?
Yeah.
Okay, so badly phrased in my opinion.
Okay.
Okay, so you're taking one, there's no replacement, you're taking the other.
Yes.
Okay, so the probabilities are going to change.
Yes.
Finish?
Yes.
Otherwise, to have done the one that I was talking about now, what would you have to have said? One's taken out and then put back, and then another one's taken out. Then they would have stayed the same. If there's replacement, probabilities stay the same. Does that make sense?
Yes.
If there's no replacement, probabilities change, yes. So the better way to phrase this question, in my opinion, was, because theoretically, I mean, I suppose you're taking, it's never really exactly the same. Okay, so, but I don't like the way they phrase it. Okay, so now, okay, with the 40s, what's happened? Okay, you've taken out a 40, right? So how many 40s are left? 2 out of 14, but there are still what? 5 out of 14 and 7 out of 14. What's your little check? Those should add up to what? 1, right? 2, 7, 14 over 14 is 1, right? Okay. Right, the next one. You've taken out a 60, so how many 60s do you have left? 4 out of 14 are 60s, right? This will still be 3 out of 14, and this will still be 7 out of 14. Do you agree? Okay, and then the last branch, you've taken out 100. There were 7, so now there'll be 6 out of 14. There'll still be 5 out of 14 there, which is 11, and there'll still be 3 out of 14 there. Are you happy with that? Okay. Then it says, everyone happy with the tree diagram? Okay. Then it says calculate the probability that the sum of the watts of the bulbs taken out is 160 watts. Okay. So how are we going to work that out? You're taking out 2 things, right? They've got to add up to what? 160. So we look for the roots that lead to 160. Okay. So 40 plus 100, 40, is there anything we can add to 40 to get 160? No. Is there anything we can add to 60? So 60, that's one possible root, right? You agree? That adds up to 160. Is there another possible root? Yeah, 100, those are not the same roots. 60 and 100 and 160 is not the same probabilities. Okay, they'll end up in times of, okay. But they're 2 roots. When I'm going along a tree diagram, what do? Multiply. Okay, here you're going to add. So basically, what you're saying is, what question is this number? 2, eh? Okay. So you're saying the probability of 160 watts. It could either be, you don't have to write this down, 60 and then 100, or, so in other words, plus the probability of 160. then 60. Does that make sense? Try to finish it off. You come to the math lesson with other things.
Why? My calculator is in my messages.
Do you think it takes?
Don't crash out.
So don't act like you don't know what it is. You know. You know what it is. This is why me and Shai always fight with the calculators. So you're not missing out so much in your day. So don't you miss us?
Every minute.
Wow, that didn't sound more convincing. Yeah, I was about to say.
So yeah, I don't know. I was too exhausted so much.
Yeah.
So, right, what's this one going to be? 60 and then 100 is going to be 5 over 15 times what? 14 plus, do you agree? Then 7 over 15 times 5 over 14. Right? Stick that into your calculator. And what did you guys get as your answer? 1 over 3.
Did you have to show that line?
This line?
Yes.
No. Okay. Right, so last one guys, then a break. Okay. It's 9:52, we should have had a break a bit ago. Okay, right. Has everyone got that down? Are we good? Okay. So, the next question. There's two ways you can do this question. When they're independent events, what that means is you can time. Hey guys, remember independence means this. Independence means, okay, that basically a tree diagram is always independent events. So what that means is independent events means that the probability of A and B is equal to the probability of A times probability of B. That's what it means. When they're telling you independent events, it's saying you can work out the probability of A and B by doing that. Okay, that's what, when they're telling you independence, if you ever ask to prove independence, this is what you have to show. You have to work with the left-hand side, and you have to work with the right-hand side, and you have to show that they're the same. They do that in contingency tables. Okay, so if they tell you they're independent, you can assume that. Stay with me. Right, so there are two ways you could do this. Okay, any suggestions? Okay, the question says, determine she wins at least one of them. Okay, how would you start this question? Probability of winning at least one. Is 1 minus the probability of winning? 1, okay. None of them, right.
Oh, yes.
Okay, so either you've got two Olympiads, right? These are complementary events. Either you're going to win at least one, or you're going to win none. Do you agree? Okay, this represents winning once, winning twice, winning both, right? Winning one of them only. So these are complementary events. Do you agree with me? What does complementary mean? It takes up the whole sample space. Either you win at least one or you win none. The fish? Okay. This is going to be easier to work out. So these are probabilities when they take up the whole sample space. Okay, what can I say? The probability of winning at least one is equal to what? What do those two probabilities have to add up to? 1, right? But they're certain, they have to happen, do you agree with me? So the probability of winning at least one is the same thing as 1 minus the probability of winning none of them, right? Do you agree with that logic? Okay. So, to win none of them, okay, what has to happen? She has to lose the first one, and lose the second one, right? Okay. The probability of her winning the first one is 0,02. So what's, let's say not winning. So what's the probability of her not winning the first one? It's 0, now what do these have to add up to?
Oh,
Either you win or you don't win. So it's going to be what? 1 minus 0,02 is what? 0,98.
Oh.
Okay. So the probability of winning is 0,02. The probability of not winning Olympiad 1 is 0,98, right? You agree with that? So the probability of not winning is 0,98. It's 2% that she wins, it means it's 98% she doesn't win. For this one, it's an 8% chance to win. So there's a 92% chance she doesn't win, right? So the probability of not winning, that is 0, what? 92, right? Okay. So, not winning both, you're going to time them together, something and something, because they're independent, right? So not winning the first one is 0,98. Not winning the second one is 0,92. So it's going to be equal to what? For two things, both of them to happen, you're going to have to times the probabilities together. Are you with me? So it's going to be 1 minus 0,98 times 0,92.
What? 0,916.
Give it to 4 decimal places.
Look at the probability.
Question says give it to 4 decimal places. What did you get?
0,906.
0,90.
901.
Oh.
They've got 0,984.
That's 1 minus.
Oh yeah, sorry. That's
What?
1 minus 0,9.
It was the answer in the end.
Yeah.
Like once you go 1, you still have to say 190. That's not the final.
Oh, the final answer, though,
Oh, you were asking. Sorry.
it's 0,984.
Sorry.
Oh, wait, I thought you were asking for 0.
Yeah,
I'm
sorry.
sorry, the whole thing. Okay.
Oh, sorry.
Right, can we do that, guys? Right, have a 15-minute break. Or 13. We start at 10. Okay. Right, go get something to eat to do. Well, they're exhausted. You arrived 40 minutes late, so it's not so bad for you. These poor guys have been.
I still was doing math from 8. So.
Well done to you.
Aren't they selling stuff on that?
My
Next week, I think.